circuit where the voltage, the relation between the voltage and the current as we have it here is that our voltage is always leading the current. For us to have to be able to determine even this power factor, it has to be the angle between the voltage and the current angle. The cos of it will give us the power factor of that particular power. Now, when we look at the current as we have VAB, we are going to take this in phases. So our VAB is, according to what we have, V voltage and current, voltage leading, then current following. So our VAB is being lagged by our IAB. That is the angle between this and this, then will become the phi, which we have to find the cos of it to give us the power factor angle. So then our VCA here also is being lagged by ICA, while our VBC is being lagged by IBC. So invariably, the angle between VAB and IAB is regarded as just phi, because we don't know the angle, we just know its angle phi. So like I said, assuming the voltage leg of the coil is connected to line B, let us assume at this instance that the voltage leg of this coil, the voltage leg is connected to B. If it's connected to line B, right, the voltage will be VAB. The voltage across will be VAB. If the voltage leg is connected to line B, it will be VAB. If it is connected to C, it will be VAC. But for now, we are trying to consider a situation where the current coil is connected to A, while the voltage leg is connected to B. That is, we are talking about this particular wattmeter A, because it is connected to line A, wattmeter A. So now, if that be the case, then the phase difference between the voltage and the current will be the phase difference between the voltage VAB, the voltage on the coil, and the angle of the voltage of the coil and the angle of the voltage angle of the current coil. The phase difference will be equal to what? What will be the difference? The difference between the voltage and the current coil. The phase difference. The phase difference between the voltage coil and the current coil. That is where the current is flowing through. The difference between the voltage will be what? Between the voltage and the current is IA is our current, while VAB is our voltage. IA is the current flowing through. So if you want to determine this wattmeter reading as it is, our WA, which is the wattmeter reading here, will be made up of the current flowing through it, IA, and the voltage across it. So the voltage across it is VAB, and the current into it is IA. So that means we have VAB and IA cos VAB and IA. So that will give us the wattmeter reading in that particular wattmeter. That is the voltage VAB and the current IA. So, and our VAB and IA times cos the angle of VAB and IA. So where is our IA here? We have IAB, right? Then our IA, if you look at the current IA, our IA is made up of IAB and ICA reverse. IAB and ICA reverse. That means our IA is equal to, because we said when we found using Kirchhoff's current law, we said IA plus ICA minus IAB is equal to 0, if you could still remember, right? And we determined that our IA will be what? IAB minus ICA. So that means our IA is made up of the sum, the further sum is made up of the IAB minus ICA reverse. So we have our IAB already, and we need our ICA reverse. Our ICA reverse, this will be our ICA reverse, which is minus ICA reverse. So the phasor sum of this will give you IA. So your IA is supposed to be a phasor sum of IAB and ICA. IAB and ICA. ICA reverse, negative. ICA reverse and IAB. That will be the phasor sum of our IA. Right. So now we want to know the angle between VAB and IA. This is VAB and this is IA. So we want to determine this angle between VAB and IA. And let's not forget that there is between line current and the phase current, it is separated by 30 degrees. That is, line current and phase current is separated by 30 degrees. Just like phase voltage and line voltage, they are also separated by 30 degrees. So if this is separated by 30 degrees, if this from here to here is 30 degrees, then it just means that, and here to here is phi. If here to here is 30 degrees and here to here is phi, so invariably it tells you that here to here is 30 degrees minus phi. So we now have this one to be 30 degrees minus phi. That settles that. So with this, we can say our VAB taken as a phase voltage, because VAB in delta form is equal to the line is equal to the phase. Our base, this is our line voltage VAB, and it is same as we have it across the phase VAB. So our phase voltage is equal to our line voltage. So we can take this VAB also, though it appears like a line voltage here, it is also equal to the phase voltage, because this is the phase. It's same phase, same voltage across the phase, which is the phase voltage. So VAB is taken as phase voltage. And IA is equal to, that is our line current. Our line current is √3 times the phase current. So we can take this one, which is our line current, IL, we can convert it into √3 I phase, because our I line is equal to √3 times √3 of the phase current. So this invariably will mean that we have cos 30 degrees minus phi, which means it is √3 V phase I phase cos 30 degrees minus phi. So that will be the reading on reading of wattmeter that is on line A if the voltage leg is connected to line B. This is what it will give you. Now, what about if the voltage leg is connected to line C? What do we get? Let's try to work that out also. If the voltage leg is connected to line C, which means it will be WA, which is the wattmeter reading in A. We want to determine the wattmeter reading in A while the voltage leg is connected to C and the current is going through. So the voltage and the wattmeter reading is VI cos phi. So that voltage that's connected to line C is VAC times the current that is flowing in the wattmeter, which is IA cos VAC IA. Right. So now we need to know what is our VAC and our IA. Our VAC from our previous phasor diagram that we had. Let's look at the phasor diagram again. That's negative. We said using the negative phase sequence, where this one, for example, is VAB, this is VBC, this is VCA, and this is IAB, right? This is IBC, and this is ICA. Right. So we want to know, this is our VCA. If this is our VCA and we are looking for VAC, our VAC will be 180-degree transpose, which will be, this will be our VAC. If this one is our VCA, this one will be our VAC. And if that is our VAC, we are looking out for IA. Let's not forget that we determined that our IA, when we have our ICA, because this is ICA, we now had I minus ICA. We had minus ICA here, right? Then we now had our IA in the previous expression. We now have our IA to be, if you go back to what we did the other time, to be summation of ICA reverse plus IAB. That gives us our IA, if you recall it very well. And we were able to determine that this is phi, and we're able to determine that between here and here is what? Is 30 degrees minus phi. Because the angle between IA and IAB, line current and phase current, is 30. Right. So if this angle, if this place is 30 degrees, no. If this between here and here is 30 degrees, and we determine that between here and here, between IA and VAB, because between VAB and IAB is phi, and between IA and IAB is 30 degrees. So we said between IA and VAB will be 30 degrees minus phi. That is this point. Will be 30 degrees minus phi. Right. So now we want to determine between VAC and IA. This is VAC and this is IA. So we want to determine that particular angle. That is what we want to determine. And to determine this angle, we know that from here down, VCA to VAC is how much? Is 180 degrees. So if from here to here is 180 degrees, and from here to here between VAB and VAC, that is face this VAB and VAC is 120 degrees. So let's take away 120 degrees from this. So 120 degrees minus 120 degrees, right? Then we have taken away this. Then it remains this. We want to take away this. This one is 30 degrees minus 5 that we calculated. So minus 30 degrees minus 5, which is this point. Right. So this will give us what? This will give us 60 minus 30. That will give us 30 degrees plus 5. That is what it will give us. So if it gives us that, then we can now say that between VAC and IA is 30 degrees plus 5. Then our WA will be what? VAC IA cos 30 degrees plus